Question 1. The table above shows some values of x and the corresponding values of y. Which of the following equations shows a possible relationship between x and y? So if this were a harder problem, I'd say go through each of the answer choices, start plugging in some of the numbers, and then see which one works. Given that this is number 1, we can pretty much just eyeball it. You'll notice that every value of y is 2 more than its corresponding value of x. 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4. So basically that just means that we're taking the x value, we're adding 2 to it, and then we get y. That's shown exactly here by choice A, and that's the answer. Question 2. In the figure shown, line J is parallel to line K. So draw my parallel marks. And line L is parallel to line M, exactly like it looks. What is the value of x? All right, so the first thing that I'm going to notice is x is vertical to this angle right here. And this angle corresponds with 40, so automatically that tells me that the answer is 40. More specifically, what we're looking at is two parallel lines cut by a transversal. And what that means is that these angles right here are corresponding, and so they're always going to be congruent. Likewise, the vertical angles here, which are equal to each other, are also going to be congruent. The only difference here is that we have added another set of parallel lines which kind of go across it. And since these two lines are parallel, they're going to divide up the equal angles or the corresponding angles in the same way. So that means this is going to be equal to that, and that's exactly what we're looking at in this problem. Question 3, the function f is defined by f of x equals that equation. What is the value of f of 4? So this is a very simple plug-in type of problem. So f of x is that, f of 4 is that, so we're going to plug in 4 for x. 4 squared minus 5 times 4 plus 6, 16 minus 20 plus 6 is going to give us negative 4 plus 6, and that's going to equal to positive 2. So B is the answer. Question 4. Arisley can spend up to a total of $20 on streamers and balloons for a party. Streamers cost $149 per pack. Balloons cost $439 per pack. Which of the following inequalities represents this situation where S is the number of packs of streamers Arisley can buy and B is the number of packs of balloons Arisley can buy? So when you're looking at this, notice what all the problems have in common. 149 is paired with S. That makes sense because streamers cost 149 per pack. 439 is paired with B, which makes sense because the balloons cost 439. So one thing we have to decide is between addition versus subtraction. Since obviously she's spending money for both streamers and balloons, we're going to have to add those costs together. So A is going to be out and C is going to be out because we're not subtracting. And then if she can spend up to a total of $20, that means she could spend $20 or less. So the total needs to be less than or equal to 20, and that's choice B. Choice D is the opposite sign, and so B is going to be the answer. Question 5. Bill is planning to drive 1,000 miles to visit his family. If he plans to drive 250 miles per day, which of the following represents the remaining distance D in miles that Bill will have to drive to reach his family after driving for n days? Alright, so if problems like this generally confuse you, the best strategy is to start picking very easy numbers for n. So let's say n equals 1. That means if he's driving 250 miles per day, he's going to drive a total of 250 miles. And to calculate the time that he'll need remaining, it's going to be 1,000 minus 250, because that's what's left over. Now let's assume n equals 2. If he's driving 250 miles per day for 2 days, he's going to be driving 500 miles. And to calculate the remaining distance, it's going to be 1,000 minus 500. So notice what's going on here just from using two examples. We're taking the number n and we're multiplying it by 250 because that's what he's driving per day. And then we're subtracting it from 1,000. So that means choice D is the answer. Given that this was number 5, you might have just been able to look at it and realize that D was the answer. But in more complicated problems, it always pays to plug in some easy numbers so you can see what's going on. Question 6. We have this expression. Which of the following is equivalent to the given expression? So notice that we've got parentheses, but we can actually ignore them because we're just using addition. So the first thing that I'll notice is that we've got a positive x here and then a negative x here. So I'm going to cross those out. What are we left with? Just an x cubed plus an x squared, and that's choice C. Notice that we had a subtraction problem, for example, a plus b minus c plus d. In this case, we would actually have to distribute the negative sign, and we can't ignore the parentheses, so that would become a plus b minus c minus d. In this case, we didn't have to worry about that. Number 7, the table gives some values of x and the corresponding values of f of x for the polynomial function f. Which of the following could be the graph of f in the xy plane, where y equals f of x? So in problems like these, what you have to recognize is that these are the x values, these are the y values, so each of these are ordered pairs. In other words, the graph is going to cross -2, -2, or -1, 3. So if I want to figure out which one of these graphs matches this table, strategically, I want to look at the place where there's the most difference. And one thing I'm going to notice is that when x equals 0, we have a lot of variation. So I'm going to look at this value first, 0, 2. And 0, 2 is going to be on my graph. What you'll notice is that each of these boxes is worth 2. So A works for 0, 2. B works for 0, 2. C does not work because the graph is at 0, 0. We'll cross it off. D is also at 0, 2. So I managed to eliminate 1. The next place that I'm going to look is back at the first coordinate, -2, -2, because there is some variation there. So choice A, the graph is at -2, but +6. So that's going to be out. Choice B, the graph is at -2, way below -2. It's probably like -2, -10. So we'll cross off choice B. And that leaves choice D for our answer. And just to check, when we're at -2, are we at -2 down there? Kind of hard to tell, but given that all the others are obviously wrong, D is going to be our answer. Question 8, we have x plus 2 over x plus 2 squared. Which of the following expressions is equivalent to the given expression where x is not equal to 2? Obviously, x cannot be equal to -2 because that would mean the denominator is 0 and therefore undefined. So for this one, it just pays to write out this expression, just expand it. We have x plus 2 divided by x plus 2 times x plus 2 again. And what we can see very quickly is that the x plus 2's are going to divide out. So that becomes 1. And so what we're left with is 1 over x plus 2. And so the answer is B. Question 9. Which of the following is an equation of the line in the xy plane that contains the points 1, 3, and 5, 15? So you could do this the real way and derive the equation of the line. That kind of takes a lot of time. What we can do is a shortcut. In other words, if each of these equations describes a line that contains these 2 points, that means we should be able to plug in either of these points and have the equation be true. So let's start plugging it in and we'll eliminate some choices. I'm going to start with using 1, 3 because the numbers are a little bit easier. So let's plug it in for choice A. The y coordinate is 3 equals 3 times 1. That's true, so we have to keep A. Choice B, 3 equals 2 times 1 plus 5. Clearly not going to work. B is out. Choice C, 3 equals 1 plus 2. Choice C is going to work, so we'll have to plug in 5, 15 after. Choice D, 3 equals 1/3 of 1. Obviously not going to work. So now that we plugged in 1, 3, let's plug in 5, 15 for the remaining. So 15 equals 3 times 5. That definitely works. And for choice C, 15 equals 5 plus 2. Not going to work. So choice C is out, and choice A is our answer because it works for both of these points. Now you should also know how to do this the real way, just in case there's a more complicated question where you can't plug in the numbers. So the real way to do this would be to use the 2 coordinates to derive the slope, and you can do that with the point slope formula. And then once you have the slope, you're going to plug in one of the coordinates with the slope to get the actual equation of the line. So how does that work? Point slope formula, remember, is going to be x2 minus x1 times the slope equals y2 minus y1. And keep in mind, this is really just the slope formula, change in y divided by change in x, but we multiplied both sides by the change in x. So you can pick any coordinates that you want. For my second, I'm going to pick 5. So 5 minus 1, mostly because it keeps my numbers positive, times the slope, is going to equal to 15 minus 3. So I have 4m equals 12. divide both sides by 4, m is going to equal 3. So now I have my slope. I'm going to use the same formula, x2 minus x1 times 3 equals y2 minus y1. And this time I'm going to take 1, 3 and I'm going to plug it in for y1 and x1. So we have x minus 1 times the slope is 3 and y minus 3. So let's multiply this out. We have 3x minus 3 equals y minus 3. Add 3 to both sides, which means they cancel out, and so you get y equals 3x. And that was the real way to do it, and that shows that the answer is still A. Takes a little bit more time, but really just do whatever is fastest for you, and that's the best way to do it. Question 10, we have this equation. It says, in the given equation, b is a constant. If the equation has infinitely many solutions, what is the value of b? So questions that ask you about no solutions or infinitely many solutions, the goal is to try to get both sides of the equation to look the same. And that'll show you that no matter what value of x you plug in, that the equation stays true and therefore it'll have infinitely many solutions. So what do I mean? First thing I'm going to notice is that, hey, we've got a 4x over here and a 2x over here. If I multiply the whole equation by 2, I'm going to have 4x on both sides. So that's going to be very helpful. So 4x plus b equals 4x plus 16. And now, for this to have infinitely many solutions, we want it to say the exact same thing. So if b is equal to 16, then the left side and the right side are exactly the same. And that means no matter what value for x that you plug in, the statement is still going to be true. So 16 is going to be our answer. The alternative way to think about this is after you've done the same thing, you've got 4x plus b equals 4x plus 16. You can subtract 4x from both sides and get b equals 16, because by eliminating the variable, you're looking for a statement that's always going to be true. So if b equals 16, then 16 equals 16 is always a true statement. So what that means is that if b is equal to 16, this is always true. Alternatively, this also shows you how to get a no solution situation, because let's say b is equal to 2, then we get 2 equals 16, not true. So what that tells you is when b is 16, we get infinitely many solutions, but when b is any other number than 16, we get no solutions. So this is a more general way of thinking about it, which could be more helpful. Sometimes I like to do it this way, where I'm just looking to make the left and the right side the same. So do whatever's easier for you guys. Question 11, it says, what is the area in square units of the figure shown? So on the SAT, one strategy is always to break up your weird shapes into simpler shapes. And on the SAT, triangles have historically been a favorite shape. So just keep that in mind. If we make a square here, that means this is 4, that's 4. And since this whole thing was 7 and this is 4, 7 minus 4, that means this triangle is 3. And this is also a right triangle. So the area of the square is 4 times 4 is 16. The area of the triangle is going to be 1/2 base times height, which is going to be 3 times 4, which is 12. So 1/2 of that is 6. Add that to 16, and the answer is 22. So that's the area of the whole figure. Question 12, what is the y-intercept of the graph of y equals 4 to the x in the xy plane? All right, so y-intercept means where does the graph cross the y-axis? And wherever it crosses the y-axis, the x-coordinate is going to be 0. So whenever you have to find the y-intercept, it just means plug in 0 for x and then see what y is. So 4 to the 0 is 1, because anything raised to the 0 power is 1. So that's the y-intercept. So they're asking for the actual coordinate. Well, x is 0 and y is 1. So 0, 1 is your ordered pair, and C is the answer. Likewise, if they were asking for the x-intercept, you would make y equal to 0 and then see what x is in that case. In this case, it's funny because, 4 raised to nothing can give you 0, so it probably doesn't have an x-intercept, but that would be the strategy to keep in mind if they're asking the x-intercept. Question 13, what is the sum of the solutions to the given equations? So what do they mean by sum? Well, I've got an x squared, an x term, and a constant. So that looks like a quadratic, except it's kind of in an annoying form. So let's subtract 2x from both sides. We get x squared minus 16x plus 40 equals 1. Then I'll subtract 1 from both sides. X squared minus 16x plus 39 equals 0. Now, obviously, it's in a much easier form to factor. So this is going to be x minus 3 times x minus 13 equals 0. And your two solutions are going to be either x minus 3 equals 0 to make the whole thing 0, or x minus 13 equals 0. So x is either going to be 3 or x is going to be 13. Add those up, you get 16, and that's the answer. So really this is just, can you factor a quadratic equation? But first you have to get it into a nicer form. Question 14, we have this annoying looking equation. So this is actually a very simple equation because all they really want you to figure out is the speed in terms of the other equations. That's the only thing you have to pay attention to here. And since we know the speed is v, that basically means take this equation, isolate v, get it on one side, and get all the other letters and numbers on the other side. So let's do that. The first thing we're going to do is we're going to square both sides. That's going to give me L squared equals S squared times 1 minus B squared over C squared. Next, I'm going to divide both sides by S squared. So that's going to give me L squared divided by S squared equals 1 minus V squared over C squared. Remember, the goal is to get V squared by itself. So now what I'm going to do is I'm going to add v squared over c squared to both sides, and then I'm going to subtract L squared over S squared from both sides. So essentially they're switching places. So we get v squared over c squared equals 1 minus L squared over S squared. The next thing we're going to do to isolate v is multiply both sides by c squared. So we get v squared equals c squared times 1 minus L squared over S squared. Now the last thing we have to do is square root both sides. So that gives us v. This part, remember, we're multiplying two numbers together, so we can't actually separate them. The square root of c squared is c, and then we'll do this whole nasty looking thing, square root 1 minus L squared over S squared. And so that gives us choice A. Question 15. The half-life of a certain substance in an aquatic environment is about 150 years. Which of the following exponential functions best models the amount in grams of the substance t years after 200 grams of the substance is applied to the aquatic environment? All right, so in any exponential function equation, they typically follow a standard form. The first number is going to be the one that you're starting out with. So given that we're starting with 200 grams, I'm going to eliminate choices A and B automatically because that's telling you that you're starting with 150. Notice that all the answer choices have 1/2 because we're talking about a half-life. In other words, the original amount, 200, is going to decrease by half periodically. So really the only question is the exponent supposed to be 150 times t, or is it supposed to be t over 150? So again, if this totally confuses you, like we said for the other problem, pick a sensible number for t so that you can see that the equation works the way that you want it to. What do I mean? Well, if the half-life is 150 years, then when you make t 150, we should be reducing the substance by half exactly. So let's do that for choice C and D. So we're going to assume first t is equal to 150. When t is equal to 150, we have 1/2 to the 150 times the 150. Now that's going to give us a really big exponent, which means that we're multiplying by a half a lot of times. The result is that 200 is going to be reduced by way more than a half. So C is not likely the answer. So we have 1/2 raised to the 150 over 150. Does this make sense? It does, because after 150 years, that means you're going to be multiplying 1/2 to the first power, which means you're only multiplying 200 by 1/2 once. So that does make sense. If you're still not convinced, let's pick the next easy number for t, where t is equal to 300. So in the first equation, choice C, it would be 1/2 raised to the 150 times 300. Again, it's going to result in too big of an exponent, and 200 is going to be reduced by a lot more than 1/2. But what about choice D? It's going to be 1/2 raised to the 300 divided by 150. That becomes 1/2 raised to 2, so it's 1/2 squared. So what we're going to actually do is we're going to multiply 200 by 1/2 once and then 1/2 again. That makes sense because if the half-life is 150 years and 300 has passed, we're multiplying 200 by 2 half-lives. So all that is to say is that if you're really confused by these equations, just plug in some easy numbers. In this case, the easy numbers were 150 and then 300 to signify 1 half-life and then 2 half-lives. Question 16. The graph of y equals mx plus b, where m and b are constants, is shown in the xy plane. What is the value of m? So based on the equation, this is slope-intercept form. M is going to be the slope of the line. What is the slope? The slope is rise over run, or the change in y over the change in x. To find the slope, given that we have the line, I'm going to take any 2 points, such as this one and this one. To calculate the rise, or the change in y, I'm going to draw a triangle. The rise is 2, and the run, the change in x, is 1. So the slope of this is going to be 2, and that's the answer. Notice that we could take any 2 points and it'll give us the same slope because the line is constant. In other words, it's straight. So the change in y here is going to be 4, and the change in x here is going to be 2. So 4 over 2 is also 2. So you can take any 2 points, find the change in the y divided by the change in the x, and that's going to give you the slope. Question 17, we've got 2 equations. It says if xy is the solution to the given system of equations, what is the value of y? So whenever you have a system of equations, on the SAT, generally elimination is going to work more often than substitution. So I'm going to multiply the first equation by 2 because what I realize is that, hey, I've got a 2x down here. If I multiply by 2 up here, I'll have a 2x. Then I can eliminate the x's and it'll get me straight to the y, which is what they're asking. So 2 times the first equation is going to give me 2x plus 2y equals 10. I'm going to move down the second equation. We have 2x equals 5. Now I'm going to subtract the second equation from the first equation. 2x minus 2x is 0. 2y minus 0 is 2y. 10 minus 5 is 5. Y is going to be equal to 5 halves. And so that's going to be your answer. Question 18, we have an equation. What positive value of x satisfies the equation? Now your first instinct when looking at this might be to start multiplying out, but do not do that because you're going to give yourself a headache. Keep in mind whenever we have a quadratic equation like x squared plus x plus some constant, ax squared plus bx plus c, usually we want to get it into factored form because when you've got 3 factors, in this case, multiplied together, which give you 0, that means one of them has to be equal to 0 in order for this to be true. So obviously 5 is not going to be equal to 0, but either x minus 3 can be equal to 0 or x plus 1 can be equal to 0, and that makes the whole equation true. So either x is going to be equal to 3 or x is going to be equal to -1. And they're asking for the positive value, and so the answer is 3. Question 19, we have an equation. What value of x satisfies the equation above? So this one is super easy. First, we're going to add 0.6 to both sides. So that's going to give us 3x equals 2.4. Then we're going to divide both sides by 3. We're going to get x equals, 24 divided by 3 is 8. So it becomes 0.8, and that's the answer. I think they just gave you this problem to see if they could confuse you with the decimals. Question 20, a square is inscribed in a circle with radius 6 rad 2 inches. What is the perimeter of the square? So let's draw a diagram. That's a circle, sort of. There's going to be a square inside. Excuse my drawing. And the radius of this circle is going to be 6 rad 2. All right, now I could draw a radius going straight up or straight across, but that's not going to be helpful to me because it's impossible to really guess what this distance is without already knowing the length of the square. A more useful radius would be going straight to the corner of the square, and that's 6 rad 2. Why is that more useful? Because what I'll notice is that if I draw another line here, this is a right triangle, and that's actually going to be a 45, 45, 90 triangle. So let's magnify that over here. We have a 45, 45, 90 triangle and 6 rad 2. So if you've memorized your proportions of a 45, 45, 90 triangle, this is the way I would do it. 45, 45, 90, and then just memorize 1, 1, rad 2. And so in this case, we have 6 rad 2 over here, which means that each side is going to be 6. If that was confusing, you can just do a proportion. So for example, we had the hypotenuse, which is rad 2 over the leg. That's our model example. And in this particular case, we know that the hypotenuse is 6 rad 2 over one of the legs. Cross multiply and then divide by rad 2. So you get x equals 6. So now we know that right here, this small part of the square is 6, which means this part is 6, which means each side of the square is 12. If they want to know the perimeter, 12 times 4 is 48, and that's the answer. By the way, the other set of proportions you should have memorized is a 30, 60, 90 triangle, and those numbers are 1, rad 3, and 2. So if you remember this and this, you're pretty much all set for those two triangles on the SAT. Remember, the SAT loves triangles, so always be looking for how you can draw triangles. And the fact that it said 6 rad 2 kind of gave me a clue in that we were looking for a 45, 45, 90 triangle because of that rad 2 there.